Hi guys, last week we were analysing and solving division problems and using shading when we were trying to find out what each part was worth, and grouping when we were trying to determine the number of parts that we had. This week we're using exactly the same bar model, but we'll be trying to work out the whole amount, so we'll be using multiplication. To begin with, let's consider what this word multiply or multiplication actually means. So you might want to pause the video for a couple of minutes just to discuss your thoughts as a class. Quite often when I ask that question, I get an answer of it means times, and people make this symbol, they make an X. And when I ask the question, well, what does that mean? It can be a bit confusing because time surely is to do with clocks and watches and what time of day it is and when's dinner and are we there yet? But here it means something different. To explain what I think this word multiply means, I'm going to use an example from a film that I saw when I was about 8 or 9 years old, and that film was The Gremlins. And in The Gremlins, a boy gets a Christmas present from his dad. He gets a cute creature called a mogwai. Now, when he gets this creature, he's given different rules, but one of the rules is that he's not to let water near it. He can't get it wet, because if he gets it wet, it will multiply. So what actually happens to this mogwai when it multiplies? Does it get any bigger? No, it doesn't grow in size. Does it split into lots of little mogwais? No, it doesn't. It doesn't divide into smaller parts. What happens is it duplicates. We get exactly the same again and again and again. So when something multiplies, we get a duplicate. If we multiply something by 5, for example, then that means we have 5 of whatever that thing is. Now, when we apply that to numbers, that means that when we multiply, we get the same again and again and again and again. To begin with, let's get thinking. I want you to consider the following statement and I want you to discuss whether you think it's true or false. But remember, I don't want you just to say that's true or that's false. I want you to give reasons. I want you to justify why you think that. It is important to memorise all of the times tables facts. So pause the video for a couple of minutes and discuss your thoughts with a partner and share those with the class. I wonder what your thoughts were in that. When I think about the times tables and what I had to learn when I was at school, we had to learn 12 times tables. So there they are there. And you can see altogether, that's 144 facts that I had to try to memorise. I don't have the best memory in the world. I can't remember what I did last Saturday, so the chances of me being able to memorise 144 facts are pretty slim. But when it comes to multiplication, what's important? Is it important that we memorise facts? Or is it important that we understand? Let's consider another statement. If you can memorise the French national anthem, then you understand it. Is that true or false? I could sit and memorise that national anthem for weeks so that I know it word for word. But I still don't understand what any of those words mean. So actually, being able to memorise something doesn't necessarily mean you understand it. I don't understand the French national anthem and I can't speak French. When it comes to multiplication, I don't want you just to be able to memorise some facts. I want you to be able to understand it so that you can apply that understanding to much bigger numbers. Because unfortunately, numbers don't stop at 12, which means we need to be able to work out what 5 times 17 is, or 7 times 234. And if we understand multiplication, then we'll be able to do that, not simply by relying on facts that we memorise. So if I was to ask you what 4 times 6 actually looked like, well, you might do different things. Some of you might write 4 times 6 equals 24, just like that. Some of you might put out 4 sixes, like we've got there. Some of you might draw 4 groups of 6. But we can take those 4 groups of 6 or 4 lots of 6 and we can make them into equal rows. So here we've got 4 rows of 6 makes 24, and this is really important. This is what we call an array, and an array is really just equal rows. And you can see there we've taken those groups and we've formed a rectangle. So the rectangle has 4 rows and there are 6 circles in each row, and that's really going to help us with multiplication. It's going to help us with our times tables, but it's also going to help us multiply much larger numbers. Arrays are really useful for helping us understand multiplication. Let's take this array here. We've got 4 rows, and you can see there are 6 dots in each of those rows. So that array there, 4 rows of 6, I know I've got 24 altogether. So we can say that 4 times 6 equals 24. That's what this array represents. Let's take that array. We're not going to change anything. I'm not adding any dots. I'm not taking any dots away. All I'm going to do is spin that array around. Now, I've still got 24 there, but this time I've not got 4 rows of 6, I've got 6 rows of 4. So the multiplication story we get from this array is 6 times 4 equals 24. So I can say that 4 times 6 is equal to 6 times 4. I can explain that using the array to help me, and that's called the commutative law. That means that any multiplication you can think of, whether it's 4 times 6 and 6 times 4, or if it's 17 times 235 and 235 times 17, then they are the same. We get the same answer. So when we multiply, it doesn't matter which order we multiply. We can multiply 4 by 6, we can multiply 6 by 4, we get exactly the same answer. We're going to use arrays to help us explore the times tables. You can choose any times table you want. I'm going to pick the 6 times table. So let's set that out. There we've got 1, 2, 3 and so on until we've got 12 rows of 6. And to begin with, let's think about which of the 6 times table are the easiest to remember. Now, I know 1 times 6, which is 6. 2 times 6, which is 12. 10 times 6, which is 60, and 5 times 6, which is 30. I'm going to highlight those because those are the ones that I can remember easily. What I'm going to do now is we're going to look at the rest of the times tables facts, and we're going to see what if we can't remember them, other ways that we could get there using what we know. So let's look at 3 times 6, and yes, I might count up 6, 12, 18. But if I know that 2 times 6 is 12, then actually I can just add another row of 6 to get my 18. What about 4 times 6? Again, I could count up 6, 12, 18, 24. Or I could see those 4 rows and split them into 2 lots of 2 rows. So actually I've just got 12 plus 12, which gives us our 24. We knew 5 times 6, that was easy. What about 6 times 6? Now again, it's getting more difficult to count up in 6s and it's taking us longer. 6, 12, 18, 24, 30, 36. But actually, I already know 5 lots of 6. 5 lots of 6 is 30. I'm just adding on another row of 6. So I get 30 add 6 to give us 36. What about 7 lots of 6? Well, for 7 lots of 6, again, I can count up, but it's taking me longer and longer. So why don't we take what we know? We know 5 times 6. I've got 5 rows there. I've got another 2 rows of 6. 2 rows of 6 is 12. So I've got 30 plus 12 to give us 42. What about 8 rows of 6? Well, let's start with 2 rows of 6. 2 rows of 6 is 12. Now, if we double 2 rows, we get 4 rows. Double 12 was 24, and then if we double those 4 rows we get our 8 rows, and double 24 is 48. What about 9 rows of 6? Well, we know that 10 rows of 6 is 60, but we've got an extra row there, so let's take away that 6, which gives us 54. What about 11 rows of 6? Well, there you can see we've got the 10 rows that we know, plus an extra row of 6, which gives us 66. 12 rows, we've got the 10 rows that we know, plus an extra 2 rows this time, which gives us 72. I didn't have to go through the times table stations in order to get there. I can use what I know and add them together. I'm making connections. Now, can we use that to extend this? Because normally times tables, we stop at 12. But multiplication goes on and on and on. So it's not just important that we can multiply up to 12. If I'm in a shop and I want to buy, for example, 6 cans of Coke that cost 65 pence each, I need to be able to multiply 6 times 65. Now, it's going to take me a long time to memorise the times tables if I'm going up as far as 65, but I don't need to. I can make connections. Let's have a look at 18 times 6. For 18 times 6, if I've got to rely on counting up in sixes, that's going to take me a long time and I might miscount. So let's have a think about how we can use this array to help us. There's our 18 rows. Now, I don't know 18 times 6. I didn't memorise that when I was younger, but I can work that out because I can think about those 18 rows and let's split that array into 2 smaller arrays. Now, there's lots of ways we can do this. We could split it into 9 rows and 9 rows. We could split it into 12 rows and 6 rows. But I'm going to go with 10 rows to begin with because I know that's 60. And then another 8 rows of 6. I know that's 48. And when I add those together, I get 108. So 18 times 6 is just 10 lots of 6 plus 8 lots of 6, which gives us 108. Maybe thinking that's a lot of dots that I'm going to have to draw if I'm working this out. So let's not draw dots each time. What we can do instead is let's put a piece of card over the top of that array. Now that piece of card is always going to be a rectangle because every single multiplication fact that you can think of makes a rectangle. So here's our rectangle. The dots are still underneath there, but this time we've got 6 in every row and we've got 18 rows. Now what did we do to that array or that rectangle? We partitioned it. We split that into 2 smaller rectangles. Instead of 18 by 6, we had one that was 10 by 6 and one that was 8 by 6. We multiplied 10 by 6 to get 60. We multiplied 8 by 6 to get 48. And we added those together to get a total of 108. It's time for you to get investigating with a partner. I've got a couple of problems that I want you to have a look at. Can you analyse them? Can you use resources to solve them? The Avengers are taking a flight from London to Berlin. A flight costs £126. What is the total cost for all 6 of them? And the second question, Nick Fury has 24 boxes of tennis balls. There are 26 balls in each box. How many tennis balls are there altogether? Once again, I want you to analyse the problems using a bar. Use the resources to help solve this. And then can you draw pictures? Can you use number lines in order to explain how you've worked that out? Let's have a look at the first problem again. So the Avengers were taking flights from London to Berlin. A flight cost £126 and we want to know what the total cost for all 6 of them was. Now, there are different ways we can work this out. We're going to look at just one way today. Here, I'm going to start by analysing it. I'm going to start by drawing my bar, and that bar represents the whole amount. The whole amount is the total cost of all the flights. How many parts am I going to split that into? I'm going to split that into 6 parts, and I'm doing that because there are 6 flights altogether. Each of those parts is the cost of just one flight. And what I can do now is put the values in I know. Well, for this problem, I know that a flight costs £126, so let's put that in a part. I also know that if one flight's £126, then I'm going to put that in for each of the other parts. So in this case here, what I'm looking to do is work out the whole amount. So how are we going to work this out? As I said, we can work this out in different ways. I'm going to show you how I would work out this particular problem myself. So I would start by collecting each of those £100 together. I've got 6 lots of £100, that gives me £600. Then I would take all those £20 notes. I've got 6 lots of £20, that gives me 120. Then I would collect in all those £5 notes. I've got 6 lots of £5, that's 30. And then lastly, I'm going to collect in those £6 coins, which gives me £6. All I need to do now is add up all those parts. We've got 600 plus 120, 720, plus 30 is 750, plus 6 is 756. So the total cost of all the flights was £756. I used actual money to solve that. Unfortunately, I don't have £756. I imagine you don't either. So I'm going to use place value counters. So I'm putting out the 126 for each part again, as you can see there. And what I'm going to do this time is I'm going to take each of those 126 and I'm going to put them into equal rows. So you can see there what I've done is created an array using the place value counters. Now, just like we did before, we can partition that. Let's add up those hundreds to give us 600. Let's add up those tens to give us 120. And let's add up those 6 lots of 6 to give us 36. So here I can add 600 plus 120 plus 36 to give us the same answer of 756. Let's have a look at the second question. Nick Fury has 24 boxes of tennis balls. There are 26 balls in each box. How many tennis balls are there altogether? So we've got a pretty horrible question here, because really what we're trying to work out is what's 24 times 26? And when I was younger, I certainly didn't memorise my 24 times table. So can we use arrays in order to help us this time? I'm going to put out what 24 lots of 26 tennis balls look like. That's a lot of tennis balls, and I'm not asking you to do that with your resources. That's going to take you way too much time. So let's not use those tennis balls. Let's put a rectangle over the top of them, and that's going to represent those tennis balls that are underneath. Now you can see there I've got 24 rows and there are 26 in each row. And like I said, I can't work out 24 times 26. So let's break it down. Let's make it easier for ourselves. Let's split those 24 rows into 20 rows and 4 rows. Now you could split it further if you want. You could split that into 10 rows and then 10 rows and then 4 rows. But I'm going to stick with 20 rows and 4 rows at the moment. Now, I've still got 26 in each row, which is a horrible amount to try and multiply. So let's see if we can split that. Let's split the 26 columns into 20 columns and then 6 columns. Now, again, we could have partitioned that further. We could have partitioned that into 10 columns, and then 6 columns. But what I've done is I've created 4 smaller arrays, 4 smaller rectangles, and actually one of those is a square. I can see there I've got a square which is 20 tennis balls by 20 tennis balls, which is exactly where we get the term square number, because the array that we make from 20 by 20 is actually a square. Now that I've partitioned that array into 4 smaller arrays, I can work out each of the parts. So let's take that square to begin with. So we've got 20 lots of 20. 2 lots of 20 would be 40, so 20 lots of 20 is 400. Next, let's have a look at 4 times 20, which gives us 80. Then we can look at the next array, which is 20 rows of 6. Now, 20 times 6, I can turn that round. It's really just 6 lots of 20. I've got 120. And lastly, we've got 4 times 6, which gives us 24. So you can see we've got an array where there's 400 tennis balls, one that's got 80, one that's got 120, and one that's got 24. All that I have to do now is add those together. 400 plus 120 is 520, plus 80 gives me 600, plus 24 gives me 624 tennis balls. It's time to discuss our success criteria. So what I would like you to do is pause the video for 2 to 3 minutes and with a partner have a think about how did we achieve success? What are the steps that we need to go through in order to analyse and solve any multiplication problem? Let's have a look at the steps that we went through in order to analyse and solve this problem. So what was our success criteria? Well, as with any problem we've looked at in previous weeks, the first place we can start is by drawing the bar. And that bar represents the whole amount. So we can describe what that whole amount is. And in this case, that was the total cost of all the flights. The next thing we can do is decide how many parts are we going to split this bar into. Now we knew that we were getting 6 flights that all cost £126, so we can split this bar into 6 equal parts. Now we've done that, we can then describe each of those parts. So each of those parts is just the cost of one flight. Then we can put in the values that we know. And in this case, we knew that each of those flights cost £126. So there we can see that we're looking for the whole amount. We're going to multiply 126 by 6 in order to work out the total cost of the flight. So the last thing we need to do is choose a strategy and solve that problem. And we solved that using the place value counters. We made an array with those. We partitioned the hundreds, the tens, and the ones, and we added those together in order to work out a total amount of £756. It's time for you to have a go and try that out. Can you apply the success criteria that we've just developed in order to analyse and solve the following 3 problems? As ever, we've got 3 levels of challenge. We've got mild, spicy and extra hot. If you're wanting to do mild, go for the yellow numbers. If you're wanting to do spicy, go for the green numbers. And if you're wanting to do the extra hot, have a go at the red numbers. So if I'm going to do the first mild problem, then I'm going to read that as Thor buys 7 concert tickets costing £23 each. How much does he pay altogether? Second one, if I'm going to do the spicy, Captain Marvel lines up 8 buses to make a defensive barrier. The length of each bus is 13.25 metres. How long is the barrier? And lastly, if I'm looking at the third question and I'm going to do extra hot, Black Panther has boxes that each contain 78 energy bars. He has 26 boxes. How many energy bars does he have altogether? Once you've managed all 3 of those and you've still got time, make up 3 problems for someone else to analyse and solve. Pause the video for 10 minutes or so. Remember, draw bars to help you analyse it, use resources to help you solve it, and make sure you're choosing the level of challenge right for you. Not too easy and not too difficult. It's time to reflect on our learning again this week, so pause the video for a few minutes and consider the following questions. What have you learned today? What did you find easy or difficult? Did you get stuck? What helped you when something got tricky? What do you need more help with? What is really making you think? And what are your next steps? The last thing I'm going to ask you to do today is, can you apply what we've learned? So as a class, I want you to discuss, analyse and solve the following problem. An adult cinema ticket costs £6.75 and a child's ticket costs £4.35. How much will it cost for 6 adults and 3 children to go to the cinema? Thanks for taking part today. Hopefully you found that useful. Remember, if you've got any questions or you want to share any of today's solutions, you can email me at scott.morrow@south-ayrshire.gov.uk. You can find my weekly maths challenges if you follow me on Twitter at scottmorrowsa, and you can find all my lessons on video at my YouTube channel, Scott Morrow Maths. Next week we're going to focus on something different. We're looking at fractions and we're looking at identifying and creating fractions. So I hope you can join me then.